Hello, this is Ms. Moreland. Welcome to the Transformations Review video. I'm going to keep this pretty short, I hope. So we're going to start with our parent function. So we've studied three parent functions, one of them being f of x equals the absolute value of x, and I want you to remember that that is the v-shaped. My computer's being slow, as usual. Alright, our second parent function is the x squared function, which is the u-shape. And note that the v-shape, the absolute value goes up 1 over 1, up 1 over 1 every time. The u-shape, you go up 1 over 1, and then you go up 4 over 2 to get to the next point. And then our last one is what I like to call the swimmer's arm, where it's the square root of x. It starts at 0, 0, you go up 1 over 1, and up 2 over 4 to get to the next point. So then with all those parent functions, we apply transformations, and they really all do the same thing. So you can have a positive or a negative in front. If it's positive, that just means it's facing upwards. If it's negative, that means it reflects the x-axis, or in other words, it flips upside down. Inside of the absolute value, or inside of the squared, or inside of the square root, we put the letter h usually. That's the x-coordinate of the vertex, but it also says whether it's shifted left or right. And on the inside, you need to remember it's opposite. So if it's a positive on the inside, that means it really went left. If it's a negative on the inside, that means it really went to the right. And then outside is the y-coordinate of the vertex, which we abbreviate usually using k. And that just tells you how it shifted up or down. And it's what you think. It's positive, it goes up. If it's negative, it goes down. So now we're going to get into some examples. So our first example here is absolute value of x minus 5 plus 4. So to get the vertex, you look at the inside and you say, well, it's a negative 5, but remember it's the opposite. So that means the x-coordinate of the vertex is positive 5. The y-coordinate of the vertex is just what it says, so the vertex in total is at the point 5, 4. The axis of symmetry is always the x-coordinate of the vertex. And it's always written with the word x equals in front of it because it's a vertical line. And it's at x equals 5. Notice that's the x-coordinate of the vertex. The translations here are right 5 and up, oops, let me move that over, up 4. And then is there reflection? The answer is no, as you see in green. So then I need to remember, well, this is the absolute value, so it's the V shape. So I'm going to go right 5 and up 4. And then this does not have a stretch. You go up 1 over 1, up 1 over 1, up 1 over 1 to get your graph. The next example, notice the parent function now is the squared. So that means I'm going to be drawing a U shape. The vertex here, notice, has a positive 3 on the inside, so that means the x-coordinate is really a negative 3. And it looks like we got a negative 2 outside, so the y-coordinate is just negative 2. Remember, the axis of symmetry is the same as the x-coordinate of the vertex, so it's x equals negative 3. And our translations here are it's gone left 3, down 2. And is there reflection? The answer is yes. There's a reflection over the x-axis, which is really all we do in this class. So again, to get there, I go left 3, down 2. No stretch on this, but it is opening down, so I go down 1 over 1, down 1 over 1 to get my u to draw, and I'm done. Alright, this next one, again, we're back to the V shape, the absolute value. Notice that on the inside with x, there's nothing, which means the x-coordinate is 0. And the y-coordinate is 3. Again, the axis of symmetry is the x-coordinate of the vertex, so it's x equals 0. We have a translation of it just shifting up 3. It has not shifted left or right, that's why our vertex is still at 0. And there is a reflection over the x-axis again. So to get this one, I go up 3 to my starting point, and then again down 1 over 1, down 1 over 1. I draw my V, and again it's upside down because of the reflection. Alright, and now we move on to the square root function. This is what I call the swimmer's arm. It's like you're swimming with one arm. So the vertex here, we're going to get the inside is a negative 5, which means the vertex is really at a positive 5, and the outside is a negative 7. So my vertex is at 5, negative 7. Again, the axis of symmetry is the x-coordinate of the vertex, so it's 5. Since the vertex is at 5, negative 7, that means that we've gone right 5 to get there and down 7 to get there. And there is no reflection for this one. So to get this one, I'm going to go to the vertex 5, -7. Okay, and this one is the swimmer's arm, so I go up 1 over 1, and if you wanted to, you can go up 2 and over 4 from the start. And that gets you your nice little arc shape there. And notice it's only going one direction. Alright, so now we're going to talk about wider and narrower. So on this first graph we have a 1/3, and on this second graph we have a 4. The smaller the number is, or closest to 0 it is, the wider it's going to get. The bigger the number is, so such as this 4, the narrower the graph is going to get. Alright, so we're going to ignore that part for now. We're just going to find our vertex. So again, on the inside here we have a -2, which means the vertex had a +2. And it's at a +3. The axis of symmetry again is the x-coordinate, which is x equals 2. And since this is a fraction, you ignore the negative. That just tells you if it reflects. But since it's a fraction of 1/3, that means the graph is getting wider. Again, the closer the number is to 0, regardless of positive or negative, the wider the graph is going to get. It's gone right 2 and up 3. And as we said, the negative is the reflection over the x-axis. So to get this graph, again, I already have it here, but I'm going to go to the point 2, 3 right there. That's my vertex. And to get to the next point, I'm going to go down 1 over 3, down 1 over 3, because I have a reflection and a vertical shrink by 1/3. Notice this one is going to be our U shape, but it's going to be very similar. The vertex here, I have a +4 on the inside, which means it's going to be really a -4. And I have nothing over here on the outside, so it's going to be at 0. And the axis of symmetry is the x-coordinate, which is -4. And again, the bigger the number gets, the narrower your graph is going to get. So if it were 5, it'd be even narrower. If it were 12, it'd be really narrow. So the translations here are that it's just gone left 4. It hasn't gone up or down at all. I also have a stretch, vertical stretch by 4. Oops, and I don't have a reflection. Ignore that. No. Let me rewrite that. No reflection. Alright, so when I do this graph, I go left 4. And notice to get to the next point, I go up 4 over 1, up 4 over 1, and I draw my U shape as best I can on this. Alright, so that's kind of the gist of drawing them and finding your vertex and all that. One thing you're going to want to study is the domain of especially these graphs. So let's go back and do a couple domains. So the domain of a parabola is always all reals. I can write here. The domain of a absolute value is also all reals. But the domain of a square root always starts at a point, so the domain of this one would be x is greater than or equal to, it starts at 5. It does not get any smaller than that because we cannot take the square root of a negative value. So we'll focus more on this in class tomorrow, but I just wanted to touch on bringing you back to domain and range. Now we're going to start writing some equations from graphs. So when you go to write equations, you're always going to want to start with your parent function so you can remember which one you're going to do. So the parent function on this is the U shape, the x squared. Then you're going to want to write the transformations. So in this case, we've gone left 3 and up 2. And notice it's also upside down, so it's reflecting the x-axis. So when I start my equation, you can start with f of x or y equals. I know I'm going to need a negative because it's reflecting. On the inside, I'm going to need a +3 because it's gone to the left 3. And on the outside, I'm going to need a +2 because it's gone up 2. Notice there are no stretches on this graph. Here's another example of the f of x squared. Now I want you to pause the video and see if you can find the transformations and the equation for this one. So the transformations are right 3 and up 1. There's no reflection on this one, so the equation is going to be just a positive in front. A -3 on the inside because it's gone right 3, and up 1 on the outside because it's gone up 1. Alright, again, pause the video and see if you can fill out the 3 things you need to for this. Parent function is the square root. Transformation is it's just gone to the left 2. There's no reflection, no up and down. So the equation I need is the square root. On the inside, I'm going to need a plus 2 because it's gone left 2. Alright, and our last graph is this. Of course, you can guess that I haven't done any absolute values. It's the V shape. This one is gone, it looks like right 3 and down 1, and then it's also opening downwards, which means it reflected the x-axis. So when I write my equation, I know I need a negative in front. On the inside, I need a minus 3 because it's gone right 3, and I need a minus 1 because it's gone down 1. Again, one thing you're going to want to study tonight is domain and range for these graphs. All right, and the last piece you're going to need to do is writing a function from words. So I'm going to give you something such as I'm giving you the parent function of x squared, so that's the only function you're using. So we're going to start pretty basic, just translate it up 5 units. So you're going to start with y equals or f of x or g of x. And I'm just going to have x squared because it didn't go right or left, and a plus 5. Pretty basic. Alright, once you pause the video and see if you can get an equation for translated left 3 and up 5 and also reflected over the x-axis. So again, I know I'm starting with x squared. I need a negative out front for the reflection. I need a plus 3 on the inside for the left 3 and a plus 5 on the outside for up 5. Right, go ahead and try the next one. This one is a vertical stretch by 3 and reflected over the x-axis. So I know I need a negative, and a stretch would mean that it's a whole number, 3. And it hasn't gone right or left, so all I need after that is just my x squared. Right, this one is a vertical stretch by 2 and translated down 4 units. So I know I need a 2x squared for my stretch, and then I need a minus 4 on the outside for it to go down 4. Right, and the last one, pause it to see what you get. Right, a vertical shrink of 1/2 means I need a 1/2 out front. I need a negative because it's reflected over the x-axis. And all I need is my x squared because it hasn't gone right or left or up or down. All right, well, I hope this was a helpful quick review for you. Have a nice night. See you tomorrow.